Consider a function like the one I've written at the top of this notebook. F of x is equal to 1 if x is greater than 0, and f of x is equal to 0 if x is less than or equal to 0. How could we implement that in Python? Well, we know how to define functions in Python, and we also know how to test whether a given number x is greater than 0 or less than or equal to 0. What we don't know is how to do one thing if x was greater than 0 and a different thing if x was less than or equal to 0. The way this is implemented in Python is by what's called conditionals, and that's what we're going to learn about in this video. The simplest kind of conditional is called an if-else conditional. An if-else conditional allows you to do one thing if a condition is true and otherwise, or else, do something else. We're going to try this in this first code cell here. First I'll define a number x which is going to be equal to 0 to begin with. Then we're going to print out a message if x is greater than 0 and a different message if x is less than or equal to 0. We do this using the word if. So we type if and then the condition we wish to check, which is here x is greater than 0. Then I'm not going to define the function above yet. I'm just going to make it print out a message. So we'll say print x is positive. As you can see, we have to indent the line following the line beginning with f with 4 spaces, just like we did when we were defining functions, so Python knows which code it's supposed to execute if the condition x greater than 0 is true. We can also have a line beginning with else, and any indented code following the line beginning with else will be executed if the condition, in this case x greater than 0, was false. So here I'll make it print out the message x is not positive. That's the simplest kind of conditional statement you can write in Python. Let's run this to see what happens. You can see on line 1 I've defined x was equal to 0, so the first condition, x greater than 0, will be false. That means what's going to happen is Python will ignore the indented code on line 3 after the if statement, and instead it will execute the indented code after the else statement. You can see what it's done is printed x is not positive. On the other hand, if I change the value of x here so that it has the value 1, this time when I execute, the condition following the if statement, that x is greater than 0, will be true. When that condition is true, Python executes the indented code following the if statement and it ignores the indented code following the else statement. So all that's going to happen when I run this is it will print the first message that x is positive. Here's a general description of the syntax for simple conditionals with an if and an else. You have if and then a condition and then a colon, followed by some indented code which Python will execute if that condition was true. So the condition must be something which produces a Boolean value, true or false. For example, a comparison, greater than or less than or greater than or equal to, or equals or not equal. Next you have optionally an else line. So that is simply the word else followed by a colon. And any indented code following that else statement will be executed if the condition was false. The else statement is optional. You don't have to have an else if you don't want to. Let's move on and look at the more general conditional statement. In fact, the most general type of conditional statement in Python, which is if-elif-else. Here, elif stands for else if, and it allows you to have multiple different conditions in your conditional. For example, you might want to define a function which had 3 different cases. You might want it to behave differently if its input x was negative, if its input was 0, and if its input was positive. To allow us to implement those 3 different conditions, we use a conditional with an elif, which stands for else if, and which allows us to add more cases to our conditionals. So here's an expanded version of the code from my previous code cell. You can see we begin by defining on line 1 a variable x equal to 0. On line 2 we begin our conditional statement just like we did before. So if x is greater than 0, and then a colon, And then on line 3 we have some indented code which will be executed if and only if the first condition, that x is greater than 0, was true. When that happens, it will print out the message x was positive. On line 4 we have our new elif. What happens here is now Python checks the condition coming after elif. This condition is x equal to 0, and you'll remember that to test whether two things are equal in Python we must use two equal signs, not one equal sign but two. So line 4 has elif, else if x is equal to 0, and then a colon. When that condition is true, on line 5, Python will print out the message x is equal to 0. Finally, we have an else clause on line 6. If neither of the two previous conditions were true, then instead the indented code following the else statement will be executed, and the word x is negative will be printed. So let's execute this. At the moment x is defined to be 0, so the very first condition will be false, but the second condition on line 4 will be true. That means Python will execute the indented code following line 4, that is the indented code on line 5, and nothing else. You can see that's what it's done. It printed out the message x is 0, which came from line 5 of my code. If I now go back and change the value of x to 1 and then rerun the code, the message x is positive is printed. The reason for that is that the very first condition after the if statement on line 2 was true. X is greater than 0. Therefore, it has printed the message x is positive and ignored everything from line 4 onwards. Finally, if I let x be -1, this time we will get the message x is negative. The reason being that both of the first two conditions, x being greater than 0 and x being equal to 0, were false. Therefore, the else clause, the indented code following the line beginning with else, is executed. Here's a general description of this syntax. You can have, in a Python conditional, as many elifs as you like. So you can make definitions involving as many different cases as you like. The way you begin your conditional with multiple elifs is, as usual, you have to start with if, and then what I've written here is condition 1, which is something which evaluates to a boolean, so true or false. Following the if statement, you put the indented code which you would like to be executed if condition 1 was true. You can then have 0 or more elif statements. Each one of these starts with the word elif, and then a condition, which must be something which is true or false, a boolean value, and then a colon. After each of these statements, you put indented the code that you want to be executed if that condition was true but all of the previous conditions were false. Finally, after your elifs, you can optionally have an else. To do this, you put the word else and then a colon, and then on subsequent lines, you put any code you want to be executed if all of the previous conditions were false. So you may have 0 or more elifs, and you may have 0 or 1 else statements. A very important thing about Python conditionals is that only the indented code following the first condition to be true gets executed. For example, if condition 1 in my code just here is true, then Python will execute the indented code after condition 1 and then ignore all of the other conditions. None of them will ever be executed, regardless of whether condition 2 or condition 3 or condition n was true or false. They won't be executed. So only the indented code following the first condition to be true is executed. Let's look at an example where that might cause problems. In the next code cell, I've started by defining a variable x which is equal to 0. I then have the beginning of a conditional. So on line 2 it says if x is greater than 0, then on line 3 there is some indented code which will be executed if x was greater than 0, and it will print out the message x is positive. On line 4 I have the start of an elif. We have elif x is greater than 10, print x is bigger than 10. But there's a problem here. That line So line 5 will never ever be executed. So no matter what the value of x, it is impossible for Python to execute line 5. The reason for that is, well, suppose the input was some number x which was larger than 10. So perhaps we'll set this x to be 20. Python defines x to be 20, then moves to line 2. On line 2, it tests if x is larger than 0. It is larger than 0. It's equal to 20, and 20 is larger than 0. It therefore executes the indented code on line 3 and skips the rest of the conditional. Only the indented code after the first condition to be true is executed. All subsequent parts of the conditional are ignored. So when I run this, you can see only the first message was printed. So how could I fix this? What if I wanted x to be bigger than 10 to be printed if x was larger than 10, and another message to be printed if x was larger than 0? Well, clearly, one way to solve this would be to move the second condition, x being bigger than 10, so that this was tested first. Let's try that instead. So I'm going to begin with the same value for x at the top. Now my first test will be if x is greater than 10. Then I have to have a colon. You can see that the Jupyter Notebooks gives me the indent automatically, so I don't have to type it myself. Print x is greater than 10. Now, if I wanted to do more things, I could add simply more indented code, but I don't. So let's now just add an elif clause, or a line beginning with elif. So now let's say elif x is greater than 0. And this time my print statement is going to say x is bigger than, actually I meant to say 0 there. X is bigger than 0, but less than 10. Now the reason I know that it must be less than 10 if it reaches this point is because if it was bigger than 10, well, actually let's be a little bit more precise here, but less than or equal to 10. The reason I know that it must be less than or equal to 10 is that if it was 10 or greater, or if it was greater than 10 rather, then the condition on line 2 would have been true, and so the print statement on line 3 would have been executed, and my elif clause would have never been executed. Let's run this. You can see it prints only the message x is greater than 10. On the other hand, if I let x equals 5, well, in this case, when we reach line 2, x is not greater than 10. Therefore, line 3 is not executed. We then hit line 4, x is greater than 0. So on line 5, the message will be printed. X is bigger than 0, but less than or equal to 10. Okay, let's return to functions with conditionals, like the one which we introduced at the start of the notebook. I'm going to write a function called sine, so not quite the function which I showed you at the top, but a more complicated version so that I have to use all the features of conditionals. The sine function will be -1 if its input is negative, 0 if its input is 0, and 1 if its input is positive. So if we want to define a function, we have to begin with the keyword def, short for define. We're calling our function sine, and its input will be called x. We then have to have a colon, and anything which comes after this, which is part of the function definition, has to be indented by 4 spaces. We want our behaviour to be to depend on the size of x, so we're going to have to use a conditional to do that. So the first thing we'd like to do is check if x is negative, in which case we're going to have our function output the number -1. So if x is less than 0, I have to type this and then a colon. My next line must be indented twice, so by 2 lots of 4 spaces, 8 spaces in total, because the next code is inside a conditional inside a function. In this case, I'd like the function to output something, so I don't want it to print to the screen, I want it to actually return a value. I must use the keyword return and then -1. And that's all I want it to do in that case. Next, I need to do something when x is 0. Since we have another case after this, I should use an elif. I need to test if x is equal to 0, which I do with a double equal sign. And what I want to do when x is equal to 0 is return, output, the value 0. Now, if I've got to line 6, that means x was not less than 0, because then the indented code on line 3 would have run. It also means x was not equal to 0, because then the indented code on line 5 would have run. So if I get to this stage, if neither of the first two conditions were true, then I know that actually x must be positive. So I don't need to have any further tests. I can simply say, else, return 1. If you like, you could do this with an elif clause, but it's not necessary. That concludes all of the three possibilities for x. Either it's less than 0 or it's equal to 0. So we've completed the definition of our sine function. Let's execute this code cell so that the sine function is defined. Now we're going to test it. When I call sine1 and run it like this, you can see the output was 1 as expected. What's happened is that when we typed in the function called sine1, Python's returned to the definition of the sine function. It substitutes 1 in place of x, and it enters the conditional. On line 2, it checks if 1 is less than 0. It isn't, so it moves on to the elif on line 4. Then it checks if 1 is equal to 0. It isn't. Now both of the conditions in the conditional were false, so the indented code following the else statement is executed. The indented code following the else statement returns the value 1. When you execute a code cell in a Jupyter notebook, it prints out the value returned by the final statement in the code cell. That value is 1, so you can see that next to the word out, it's printed the value 1. Let's try this again with some different inputs to test that our code works for all possible inputs. We'll try sine of 0. Again, we've got the answer 0, as expected. So finally, let's check that it does the correct thing for a negative number. Let's try minus 99. Again, you can see that it's done the correct thing. The specification was that it should return minus 1 when its input is negative, and that's what it's done.